Human population growth, it has a major impact on the planet. We need to be able to predict the population in order to really discuss how the impact is going to change. Now, in the I-PAT relationship, I've been clear to say that it's not just multiplying population times affluence or consumption times technology, but population really is a major multiplier of the impact. The more people we have, the more resources they take up, and the more space and water and energy they consume, and that ends up in a larger impact. So we really need to be able to predict what is going to happen with the human population. In lecture, we're talking about the demographic transition as one model for how population growth rate is related to technology and affluence. But I just want to go through these predictions here to set the stage for how we would use that how we would understand that using scientific models. So there's models for human population growth, and these models are based on underlying assumptions. One is very optimistic, populations will be manageable. Another is cautious, that again, if we work together and take precautions, we might be able to minimize negative impacts of too many people. There's a couple others that human population will actually decline, or that it not only decline, but it will be catastrophic, sort of like the population crashes in the book Collapse. So if you look at these four models, you have the long-term increase just inching up all the time with the population getting higher and higher. There's the green one where it's leveling off at some sort of intermediate, higher than present day, but manageable level. There's a red which might include this sort of overshoot, or might even come from lower levels down in here, but there's a readjustment. We'll end up with a lower population at some time. There'll be a decrease in population. And then there's this catastrophic characteristic where it shoots up, and then because of disease or resource limitation or a combination of everything, we have a very large decrease in human population. So we're not picking one of these models as being correct or incorrect, but there's a large degree of uncertainty in all of these predictions, and those sources of uncertainty are the changing conditions, human decisions, and all of these are related to population itself, what the population decides to do, resource consumption, human choices, and then things that technology may or may not be able to affect, such as susceptibility to disease or economic growth. So we can use science to explore these possibilities, but we can't ever pick one as being this is going to be the outcome for human population. So that leaves us with this I-PAT relationship being a complex system like we talked about in lecture. All factors are interacting and constantly changing. We can, however, deal with the near term. What's the current rate of change? What do we assume about the stability of the countries and regions, and what are the known resources and technology? And we can extrapolate that out pretty, over a few years to a decade maybe, and be very comfortable about that. And again, this is coming back to one of the themes of the course, is if we focus on the short-term changes and short-term uses of technology, maybe that's all we can do, and we can try to take the future just increasing the quality of our environment just a little bit at each time.